Number 6. Give the image of the point 5, negative 3 after a reflection across A, the x-axis, B, the y-axis, C, the line y equals x, D, the line y equals negative x, and E, y equals 1. So the first one we're going to look at is A, the reflection across the x-axis. If you'll remember, the rule for that is x and opposite y. So we go back to our pre-image point, and our 5 is going to stay the same, and the opposite of negative 3 is positive 3. So the coordinate for A is 5, 3. B, you're reflecting across the y-axis. This time it's opposite x, and the y stays the same. So the opposite of 5 is negative 5, and the negative 3 stays the same. C, you're reflecting across the line y equals x. The rule for this is your x and y just change locations. So your y becomes your x, and your x becomes your y. So all we have to do is switch these around, so it's negative 3, 5. D is reflecting across y equals opposite x. This time your rule is just the opposite of what you did when you reflected across y equals x. So the opposite of y, the opposite of x. So the opposite of negative 3 is positive 3. The opposite of positive 5 is negative 5. On E, you probably want to draw a graph to figure out the reflection across y equals 1. Y equals 1 is a horizontal line that goes through 1 on the y-axis. So here is your y equals 1. The point 5, negative 3 is right here. That's 5, negative 3. If you'll remember, when we reflect across a horizontal line, the x value does not change. So our x value is going to remain 5. And your y value has to be the same distance away from this line of reflection. So if the line of reflection is at positive 1 and our point is at negative 3, that's 4 units away. So our point, when it's reflected, also has to be 4 units away. And if we're at 1 and we add 4 to that, we end up at 5. So our y value is 5. So the coordinate for E is 5, 5.